All right, so I'm going to do a couple more. I realized that last one was actually 25 and not 26, so let me give you 26. This is out of section 10.6, of course. And so that one is 4y squared plus z squared minus x minus 16y minus 4z plus 20 equals 0. So we're going to identify what kind of surface it is. If it's easily graphable, I will graph it. Okay. So one thing I notice is that the x term, there's no x squared term. So it looks like it's going to be one of these paraboloids. Okay. So let me put it into the right form. Again, I'm going to put the y, z, and x terms together. There's not really any x terms. So let's put the x on one side. And we're going to have 4y squared minus 16y plus z squared minus 4z equals x minus 20. Okay. Well, before I do that, let me factor out the 4 in the y terms. Getting it ready for completing the square. Just rewriting the z squared. Now, what am I going to have to add? Again, I'm taking half of this 4. Okay, half of that 4 is 2. Squaring it is 4. So I'm going to add 4. On this side, that means I add 16. Because remember, I'm adding 4 times that 4. Over here, I'm adding 4 again. Adding 4. So I get 4 times y minus 2 squared plus z minus 2 squared equals x. Okay, so again, this is kind of like a cone, but it's got this 4 in there, and it's also got the minus 2 in there. We know where it's centered at. It's centered at 0, 2, 2, right? Because if you have those points, you're going to have 0 in there. So 0, 2, 2 is sort of the center of this paraboloid. Okay, next thing is we're going to consider, what if we had x equals y squared plus z squared? Okay, and that's going to tell us the basic shape. If we had x equals y, x equals y squared plus z squared, that would mean that you have, like a parabola like so. Okay, that's x equals y squared, and it's going to go around like so. Okay, now we're going to move it a little bit. The actual parabola is going to be centered at 0, 2, 2. So okay, and then it's still going to go out that way. So it's going to go a little farther, a little more in the y, but I'm not really going to be asking you to do that, but it's going to be more narrow in one direction than in the other. Okay, really what I'm concerned with is, can you find the formula and identify it? So this is a elliptic paraboloid. Okay. All right, let's do one more. Let's take x squared plus 4z squared plus 4 equals y squared. Okay, so I'm going to write this as x squared plus 4z squared minus y squared equals negative 4. I don't like that at all. I don't like that negative sign. So let's change it up. How am I going to change that up? That's going to be y squared minus x squared minus 4z squared equals 4. Okay. So now, again, I'm going to pretend that this 4z is instead just z. So let's call it, I don't know, w. So let's let u equal 2z. Oh, I said w, didn't I? Okay. So I'm going to take y squared minus x squared minus w squared equals 4. Okay, and now I've got a symmetry of x and w. Okay, so y is sort of the odd axes out. Okay, so this is x, y, and w. And what do I have if I just look at like the y-x? That's going to be a hyperbola, right? A hyperbola in these two dimensions. Okay, so let's draw it. Hyperbola, let's actually do it in y and w. Okay, so we're going to sort of pretend x is 0. Okay, so that means that sorry, give me just a second. So we're going to be rotating it around the y-axis because that's the one that's not symmetric. Okay, so okay, give me just a second. Sorry, y and w. So it's going to be going out in y. Okay, and it'll go this way. So this is a two-sheeted hyperboloid. Again, because you've got the two pieces. And if I wanted to do it perfectly correct, what I would have to do is I would have to make it go a little bit thinner in this direction. Okay, because the actual hyperboloid, remember, is going to be y squared over 4 minus x squared over 4 minus z squared equals 1. Okay, so that means it'll go 2 out, the rectangle will be 2 in y and x, but just 1 in z, so it'd be a little more narrow. Okay. which I have no idea how to draw that well. Yeah, no idea how to draw that well. Maybe a little fatter in this direction. Okay, but that's not really what I want you to worry about. I want you to worry about getting it into the form where you can tell what kind of object it is. Okay, so there is a chart on page 578 in your textbook where you can get all the different quadric surfaces. But I actually like to just try to draw it, try to see which one I can find symmetry in, you know, by playing around with it, which one is the odd man out, and then drawing the two-dimensional picture and then rotating it around the appropriate axis. Okay? All right, I'll see you all in the next set of videos.